Hello students, this is Sir Murtaza from Al Murtaza School and welcome you to another lecture of physics. So let's start. So first of all, what we are going to do, we will look upon the agenda or the topics that we are going to discuss or learn from this lecture video. So what is our agenda? So the agenda for today's lecture is that we are going to cover some SLOs. Okay, so what SLOs we are going to cover in this lecture? We are going to cover differentiate between base and dry physical quantities. It means that in our first SLO, we are going to discuss about the differences between base and dry physical quantity. Then list the 7 units of international system units along with their symbols and physical quantities. So in this SLO, we will look upon the list of physical quantities along with the symbols and units. Okay. And in the last, we will talk about the significance of international system. Okay, so firstly we'll talk about our first SLO, which is 1.3.1. So this is our first SLO, which is the differences between base and dry physical quantity. So as we are going to discuss about the differences between base and dry physical quantity, so definitely we will be looking on a table where we can see the differences between these quantities. So whenever you talk about the differences, so the differences, the number one point for the differences you say is the definition. Okay, then a little more elaboration and then examples. Okay, so we will do the same thing. So here is the table. Okay, in this table you can see that there is a table which shows the differences between base quantities and dry quantities. So firstly we will talk about its definition. Okay, the definition of base quantity is these are the quantities on the basis of which other quantities are expressed. Okay, we have learned that the base quantities are also called as the fundamental quantities, and on the basis of this base quantities, other quantities are expressed. Okay, while the definition of derived quantity is the quantities that are expressed on the basis of base quantities. Okay, so derived quantities, as the name defines, it is based on something or it is derived by something. So derived quantities are expressed on the basis of base quantity. This is our first difference between base and derived quantities. Then the next point is there are 7 base quantities. Okay, you have to remember that there are 7 base quantities. Okay, there are only 7 base quantities, while if we talk about derived quantities, there are numerous derived quantities. Okay, we can't give a specific number to derived quantities. There could be numerous derived quantities, while for base quantities there are only 7 base quantities. Okay, then if we talk about its examples, so the examples of base quantities are length, mass, time, etc. While the example of derived quantities are speed, acceleration, volume, etc. Okay, as you can see that speed, volume, or acceleration, it is based on what base quantities. If I talk about speed, so it is meter per second. So there are 2 base quantities. Okay, so these are the differences between base and derived quantities. We have to remember the differences. Okay, and this is a very short SLO in which we discuss what are the differences between base quantities and derived quantities. Okay, now move on to the next SLO. So the next SLO is list of physical quantities along with the symbols and units. Okay, as we have discussed before, I told you that whenever we talk about a physical quantity, so it should have 2 characteristics. One is its magnitude and other is its unit. Okay, so here I will show you a table. There would be list of physical quantity. First we will talk about base quantities and then we will talk about derived quantities. We will see what are the base quantities, its symbol, and what is its unit and its symbol. Okay, so here I'm going to show you a table. So this is a table. In this table, you can clearly see that, as I've told you, that base quantities are 7 in number. So you can see that there are 7 base quantities, which are length, mass, time, electric current, intensity of light, temperature, amount of a substance. And in the next column, you can see its symbol. So let's talk about it one by one. So firstly, I'll talk about the length. Its symbol is small l. Okay, length is represented by a small l. Its unit is meter and its symbol is small m. Okay, you have to remember it. Next we talk about mass. The symbol is small m, its unit is kilogram and its symbol is kg. Then time, its symbol is small t. Okay, its unit is second and it is represented by small s. Then electric current, its symbol is capital I. Okay, its unit is ampere, and its symbol is A. Okay, then intensity of light, its symbol is capital L, its unit is candela, and its symbol is CD. Okay, then we talk about temperature. Its symbol is capital T. Okay, here I will tell you that you have to differentiate between time and temperature. You can see that time is also represented by T, but it is small t, okay, while temperature is represented by capital T, okay, and its unit is Kelvin and its symbol is K. And in the last, we have amount of a substance. Its symbol is small n and its unit is mole and its symbol is mol. Okay, so this is the list of base quantities which you have to remember. There are 7 in number. You have to remember all its name and its unit along with its symbol. Okay, now we will talk about the derived quantities. As I told you that there are numerous derived quantities, but I will just show you 7 derived quantities. Okay, so now we will talk about drive quantities and their SI units with symbols. So here is the list. Okay, so in this list, you can clearly see that first we are talking about the quantity, its unit. So let's talk about one by one. So first we have speed. Its symbol is V, okay, and its unit is meter per second, okay, and its symbol is ms minus 1. Okay, you can also represent it by either ms minus 1 or meter per second, okay, like meter slash then second, okay. Then acceleration, its symbol is small a, okay, and its unit is meter per second square, and its symbol is ms minus 2, and again you can represent it by meter per second square, like meter slash second square, okay. Then we have volume. Its symbol is capital V and its unit is cubic meter. Sorry, there is a spelling mistake. You just correct it. It is cubic, not cuboc, cubic meter. It is represented by meter cube. Then we have force, okay. It is represented by F. Its unit is Newton and it is represented by either capital T or its another unit is kilogram meter per second square, but mostly we use Newton for force, okay. Then we have pressure. Its unit is Pascal and its symbol is either PA or it is also represented by Newton per meter square. It depends, both are the same, but mostly we use Pascal, okay. Then we have density and its symbol is rho. This is rho called, it is not actually a P, it is a little, similar to P, and we call it as rho, RHO, okay, and its unit is kilogram per meter cube, okay, which is represented by kg minus 3. This is a symbol. And lastly we have charge. Its symbol is q, its unit is coulomb, okay, and it is represented by either capital C or as, but mostly we use capital C for coulomb, okay. So these are the list of drive quantity, and again I will just tell you that there is a little mistake here, spelling mistake. This is cubic meter, okay, just correct it out, okay. Now we are moving on to our next topic. So the next topic, and this is our last SLO for this lecture. In this SLO, we are going to discuss about the significance of international system. Okay. Before this, I just want to tell you that whenever you want to communicate with someone, so you have to know its language. It is very important to communicate with someone to know its language. Without knowing its language, you can't be able to understand it. Okay. In the same manner, whenever we talk about a physical quantity, so it should have a common unit, okay, and that common unit is known as international system. So what are the significance of international system? Let's look on to this. So here it is that with the developments in the field of science and technology, the need for a commonly acceptable system of units was seriously felt all over the world, particularly to exchange scientific and technical information. Like I said, with the development of field of science and technology, we need to have a commonly acceptable system of units. Okay, for what? In order to exchange scientific and technical information. So this is why SI units are very significant. Okay, then thus the 11th General Conference on Weight and Measures held in Paris in 1960 adopted a worldwide system of measurements called International System of Units, also commonly referred as System of Units. Okay, thus in order to overcome this problem, a conference was held in Paris in 1960, and there they have adopted a worldwide system of measurement called International System of Units, which is also called as SI units. So previously, what I have shown you the unit for the physical quantity that were its SI unit. For example, if I talk about length, its SI unit is meter, but we definitely know that length has also a unit of centimeter, or you can say that if we measure a length, we can also measure it by feet or centimeter, but the SI unit is meter. Okay. Likewise, if we talk about mass, its SI unit is kg. Okay, but we can also measure mass in pounds or grams, but the SI unit is kg. So you have to remember the physical quantity along with its SI unit. And previously in the table that I have shown for base and drive quantity, all the units were their SI units, and its significant is because whenever we are talking about uh, whenever we are sharing information about scientific and technical, so we have to have a commonly acceptable system of unit. So this is its significance. Okay, so this is it for this lecture. In this lecture we have covered 3 SLOs, and hopefully you have understood all the topics. So till then, Allah Hafiz, and we will inshallah meet very soon in our next video. So till then, Allah Hafiz.